This is Mr. Martin. These are the video notes for Geometry Honors, section 12.1 and 12.2. We're going to be talking about surface area of prisms first. So let's take a look at some vocabulary and some definitions. So first, a polyhedra. It's a three-dimensional solid comprised of flat faces. Each face is a polygon, and the intersection of the faces are segments called edges, and then the edges are going to meet at vertices. So when we're talking about a prism, we want to look for bases. And the bases are going to be the two parallel and congruent faces. So this is important. The two parallel and congruent faces. Because in the pictures here, all of these figures kind of have the bases on the top and the bottom, but they don't necessarily have to be on the top and the bottom, and you don't want to get confused. The bases don't have to be top and bottom. They can be left and right as well. So keep that in mind when you're looking for the bases. We also have lateral edges. These are the parallel segments joining the vertices of the bases. So if I take a look at this triangular prism here, I have this lateral edge, this is a lateral edge, and this one in the back are lateral edges. They connect the vertices of the bases. The bases are triangles, and they're all going to be congruent, and they're all going to be parallel. Okay, so keep that in mind. And then we have lateral faces. So these are the non-parallel faces of a prism, and these are going to be parallelograms. Most of the time they're going to be rectangles, but sometimes they can be parallelograms. Alright, so if we take a look at this rectangular prism, this is kind of an exception, and the cube as well, because each pair of opposite face is parallel and congruent. So really you can, for a rectangular prism or a cube, you could use any pair of opposite faces as your two bases. Okay, with the pentagonal prism, the pentagons are going to be the bases. With the hexagonal prism, the hexagons are going to be the bases. And keep in mind, we don't have to have regular polygons, but a lot of times we will. So when we name prisms, prisms are named based on the type of polygon that makes up the bases. So as you can see up here, since the bases are pentagons, this is a pentagonal prism. A right prism is a prism in which the lateral edges are perpendicular to the bases. So again, if we come up here, all of these are right because we can see that each of the sides is perpendicular to the base. And most of the ones that we deal with are going to be right prisms. Once in a while, we'll have ones that are not. Lateral surface area. So these two things right here, these are going to be important. You need to understand. So for lateral surface area, this is the sum of the area of just the lateral faces. So we're not going to include the two bases. All right, and most of the time I'll abbreviate this as LA, lateral area. So a lot of problems will ask for the lateral surface area, and they'll ask for the total surface area. So you're going to have two answers. And to find the total surface area, you're going to use your lateral surface area answer, and then just add on the two bases. And then for total surface area, I'll just abbreviate that TA. Alright, so let's take a look at an example here. We want to find the diagonal of a cube with a total surface area of 1,296 centimeters squared. So here's my cube. And I know, since it's a cube, that each face is going to be a square. I know that my three dimensions are all going to be the same, so I'm going to call those S. And I know that each face is going to have an area. So each face, the area is going to be S squared. And then, since I have 6 of those, the total area is going to be 6 times the area of one of the faces, and we know that the total area is 1296. So that means that the area of each face, that means that s squared, which represents the area of each face, is going to be 216, which means that s is going to be the square root of 216. So now that we know that each of these sides is the square root of 216, remember we have a formula for the diagonal of a rectangular solid. It's the square root of x squared plus y squared plus z squared, the three dimensions. And in this case, they're all the same. So it's going to be the square root of square root of 216 squared plus square root of 216 squared plus square root of 216 squared. Or you could have written it as 3 times the square root of 216 squared. So this turns out to be the square root of 648, because for each of these, the square root and the square cancel, so it's just 216 times 3, which is the square root of 648. And if I simplify this, I know it's going to be the square root of 324 times the square root of 2. And the reason I picked 324 is because that's a perfect square. That's 18 squared, so we have 18 root 2. So there's the diagonal of the face. So that's it for section 1. Moving on to section 2, we're looking at the surface area of a pyramid. So for a pyramid, it's a three-dimensional solid with one base. The lateral edges meet at a single point called the vertex, and the lateral faces are triangles. So in this case, I have a square base, and then I have 4 triangles. So a regular pyramid is a pyramid that has a regular polygon for the base, like this one is a square, and the lateral faces are all congruent isosceles triangles. So make sure you realize that they're isosceles. They're not necessarily equilateral. And again, don't assume that you have 30, 60, 90s or 45, 45, 90s unless you know for sure or you can prove it some way. So the parts of the pyramid, we've got the altitude. That's the segment that joins the vertex of the pyramid to the center of the base. So in our picture here, it's H. We have a lateral edge. That's the intersection of the lateral faces. So a lot of time for a lateral edge, we'll use L. Actually, we use that for slant height, L, so I'm just going to call this Y. So that would be Y, and then there would be 4 of those going around. And then the slant height, in this case, it's labeled as A, but normally we use L for the slant height. And we'll look at that more later. So we've got the parts of the pyramid. Here we've got a hexagonal pyramid. It's a regular hexagonal pyramid with base perimeter 72 and altitude 8 root 3. And we want to find the lateral surface area and we want to find the total surface area. So for the lateral area, it's going to be 6 times the area of the triangles. Alright, so we need to find the area of the triangles. Since we know that the perimeter of the base is 72, and we know that it has 6 sides, so I'm going to call this S. So I know that 6 times S is going to be 72, which means that S, each side, is going to be 12. So we know each side of the base is 12. I'm going to draw in the height here because we're going to need that. So that goes right to the middle. And I'm also going to draw in an apothem right there. And I'm also going to draw in a radius of the polygon right there. And I'm going to give this some letters so we can talk about it. Here's A, here's B, here's C, and then here's D over there. So there's B and C. And then it's kind of hard to tell in here, but the right angle is right over here. Okay? So if I look at that little triangle there, I'm going to redraw it out here. That would be D, and this would be C, and that would be B. And here's my right angle, because that's my apothem. So, and then since each side of my base was 12, I know that BC over here has to be half of that, so that's going to be 6. And since it was a regular hexagonal pyramid, I know when I draw this triangle, it's going to be a 30, 60, 90, where that's my 60, and that's my 30. Okay, so this radius has to be 12, and this apothem has to be 6 root 3. Okay, and then I'm going to draw in a slant height here. I'm going to draw that in a different color so you can see it a little better. So I'm going to draw in this slant height right there, AC. So segment AC is a slant height. Okay, and the slant height here is really going to be the height of that triangular face. So in order to find the area of triangle, let's put another letter in there, ABE, I'm going to need to know AC, which is its height, and BE I already know is 12, so I'm going to do half 12 times whatever I find out for the height there. So I'm going to redraw triangle ABC there. Again, the slant height is going to be perpendicular there. And I know here's my B, and here's my C. And let's see, I wanted to look at a different triangle first, but so let's keep this one. Let's keep that triangle, A. And then before we look at that triangle, let's look at triangle ADC. So we had an altitude of 8 root 3 in there. 8 root 3, that's my altitude. So let's look at triangle ADC first. Here's A, here's D, here's C. I know that this is 8 root 3. And this is my DC, which is over here, is 6 root 3. So I can find AC. So AC squared is going to be 8 root 3 squared plus 6 root 3 squared. So if we go ahead and work that out, just to save time, I'm going to tell you what AC is. That's going to be the square root of 300, which is going to be 10 root 3. And then I can find the lateral area. So that's going to be 6 times 1/2 the base, which is 12, times the height of that face, which is the slant height, which is 10 root 3. And if we go ahead and figure that out, it's going to end up to be 360 root 3 units squared. So then to find the total area, I just have to add in the regular polygon base, so that's going to be 1/2 AP, so that's for the base, plus the lateral area. So that's going to be 1/2 times 6 root 3 times 72 plus the lateral area, which was 360 root 3, and that gives us, should give us 576 root 3 units squared. Alright, so if you have questions about that, make sure you write them down and ask them the next time you see me, and we'll see you next time.